What's going on, good people? What's going on? It's me. I'm back with another video. I know it's been a while since I've done one of these, and the reason why is because I've been fully immersed since January 1st in, youth football coaching. Our season ended, I would say, first or second week of November. We finished third in our league. We didn't obtain the ultimate goal, the ultimate two goals that we had, which was making it to the Super Bowl and making it to nationals. But it still was a hell of a season. So thank you to Coach Jamal, Coach Charles, Coach Norm, and Coach Chris for being a part of the staff, as well as thank you to the players. The season wouldn't have been what it was, excuse me, without you guys. So once again, I truly thank you guys for that. So with that being said, for the better part of a year, I was working on a CloudRC car. I was working on it kind of on and off, nothing serious. And the issue that I was having, or what was slowing the whole process down, was I wanted the creating the RC car isn't the issue. It's the software portion of the Cloud RC car that was the issue. I had a few iterations of, Python versions, WPF versions, all these versions, they look great, but they didn't function great. I've recently switched to a Pygame version of the software, and the creation of the Pygame software has been the most fruitful. Um, and I'm actually loving it because it's actually coming out exactly the way I want it to come out. So with that being said, we're going to get into the components of the Cloud RC car, and the first component is the Raspberry Pi. The Raspberry Pi originally was the Raspberry Pi 4, and that's since been upgraded to the Raspberry Pi 5. And the reason why is because this Raspberry Pi 5 comes with 16 gigs and a better processor, which allows for better T-flops. So that just allows for better functionality with all of these sensors connected to this Raspberry Pi 5. The next thing we're going to talk about is the ArduCam IMX477. This is the eyes of the entire system. This camera is a 12 megapixel camera connected to a CCTV lens. The CCTV lens, the only downside about it is it doesn't have a motor that controls the zoom or the focus of the camera. So right now I'm working on an apparatus that's going to connect to that portion of the lens and allow for me to control the zoom remotely um, from the G29 wheel, and we'll get into that in a few. The next thing that you see here is this blue USB cable running to this device right here, and this is the ultimate GPS. That's what's going to give me my latitude, longitude, GPS fix or satellite fix, as well as miles speed and miles per hour. The only issue with this device is this device needs to be connected to actual GPS satellite. Now, if it was connected to a tower or was using a cell phone or mobile service and connected to a tower, then it would get real-time GPS data directly to the device. So I'm thinking about switching to that type of GPS module, so that way we can have real-time data, and we don't have to wait for GPS satellites to come into range so that this can connect to. The next thing is the PCA 9685 board, and this is where all of your servos will be connected to. Your ESC will be connected, steering servo, brake servo, and your continuous servo for the zoom. Now, this is your pulse width modulation device. This is what's going to control those high and low frequent or signals that are coming from the servos. Because if the servos are directly connected to the Raspberry Pi, then the Raspberry Pi isn't designed to handle those high and low signals very well. So it can cause issues with the Raspberry Pi while it's functioning, as well as it can cause servo jitter. So that's what this device is for. And it allows you to run multiple servos at the same time. Also, what's going to be connected to this a little bit later are the lights, tail lights, headlights, so for nighttime rides. The next thing is the ADXL 345 board. Now, the ADXL 345 board is going to give us our X, Y, and Z telemetry. The X position is the left and right. The Y telemetry is going to be your forward and back. And then the Z is going to be your up and down. The next or last component in this system is your INA 260 board. That's going to monitor your voltage, current, and power. So there's going to be a separate battery for the Raspberry Pi, a separate battery for the car, a separate battery for the lights. So all those batteries are going to run into this device right here, and that's going to provide me with how those batteries are working within the system. So that way, if we have any type of issues with our batteries, we'll know directly from the app itself. And then lastly is the control of the RC car. I'm not using a traditional controller. I am using a Logitech G29 sim wheel. The Logitech G29 sim wheel, this is going to give you my left and right, and this is what's going to give you my zoom. And then the pedals down here are going to give me throttle and brake. Now, as far as the software is concerned, there is software that runs on the Raspberry Pi as well as there's software that runs on the PC, and they both talk to each other. How you start the app or how you start this whole process is you first have to start the software that runs on the Raspberry Pi, and that's what we have here. So you can see I'm on version 20 of the software, and that's how long I've been, that's how many iterations of the software I've gone through or of the server code that I've gone through to get to this point right here. And nothing is better than failure, because failure is what leads you to success. So you can see here that the PCA 9685 board is successfully connected. The ADXL is connected. The INA, 260 board isn't connected. And the only reason why is because I'm having a bus issue with that device. So once I figure that out, then we'll, be able to have this data, this telemetry being fed back to the car. The next thing, you can see the GStreamer pipeline is running. You can see our GPS is functioning too as well. The only problem, like I told you guys, there's no GPS satellites overhead. Those won't be overhead until maybe 1, 2, 3, 4, 5 o'clock in the morning. And I'm not staying up that late just to get that type of telemetry. It's motivating me to switch to the um, switch to a mobile signal so that way I can connect to, or SIM card so that way I can connect to the tower. And then you can see here that our WebSocket server is started, and this lets you know that your camera is functioning fine. So you can see here the Mk6 camera is functioning perfect. So the next thing we do is we go over to our computer, and then we run the software from the computer. Let's go ahead and do that now. So you can see it connects automatically, and so you can see here, these panels here let us know whether the WebSocket server is connected. This lets us know whether our steering wheel is connected, is the video streaming. You can see the ultimate GPS, ADXL, and then our power, and then this gives us our Logitech G29, basically the position of the steering wheel. And as I turn the wheel, you can see that that's moving. I can hit the brake, there's the throttle, and then as I turn the wheel on the steering wheel, you can see that that's functioning too as well. And then also we do have our camera stream. So like I said, the camera is the eyes of the entire application. And it might look a little bit blurry for now, but once again, that's the manual adjustment that needs to be made. And once you find that sweet spot, um, it creates a clear, very, very clear picture. And then the last thing we need to do is we then need to go ahead and connect to the software, or to the application, I should say. And then you can see here, you're receiving your telemetry data from each one of the sensors. And the reason why they're set to null is because we just want to make sure that the sensors are working, that we're receiving something from the sensors. We don't need exact telemetry for now. We just need to know that the sensors are working. And now that we know that the sensors are working, now we can make adjustments to the code that will then give us more accurate telemetry data. So we got our steering wheel, and you can see in the server code, it's responding to the steering wheel. And then as we hit our throttle, it's responding to the throttle. And as we hit our brake, it's responding to the brake. And as we hit our zoom on the wheel, it's responding to the zoom within the software too as well, or the server code, I should say. So that's what I have for now. Stay tuned for updates. Let me know what you guys think about it. I will be displaying the actual RC car Obviously, it is a Nissan GTR R34. This is Project GTR Mk6. It's a 1/5 scale GTR, hard body, beautiful body lines, excellent condition, and that is what's going to make the maiden voyage, as they say. So like I said, stay tuned. Let me know what you guys think in the comments later.